Hi everyone, welcome back to my YouTube channel. In today's video, we'll learn about the half wave rectifier. So this is the one type of the rectifiers. In this video, we will see the complete information about half wave rectifier, like its definition, its construction, its working, and the waveforms. And also we will see the parameters of these half wave rectifier, like efficiency, RMS value, ripple factor, peak inverse voltage, transformer utilization factor. And also we see the disadvantages of this half wave rectifier. So if you want the basics about these rectifiers, I already uploaded a video on the DC power supplies. So if you want to watch that video means I will provide the link of that video in my description. So please go and watch that video, then you can understand these concepts very clearly. So before we start, so do subscribe my YouTube channel and share this video with your friends and comment below with your suggestions. So now half wave rectifier. So this half wave rectifier is an electronic circuit that converts an alternating current signal into the pulsating direct current. See, we have different types of rectifiers, that is half wave rectifier. In full wave rectifier, again it is classified into two types, that is center tap rectifier and the bridge rectifier. Every rectifier function is same, that is converting from the AC to pulsating DC. So coming to this half wave rectifier, it is also converted from the AC to pulsating DC by allowing only half of the signal. That signal may either the positive or negative, but it will allow only half signal, and another half signal will be blocked. So that's why it is called half wave rectifier. Means it allow only half of the signal. That half of the signal may be either positive or negative, and other will be blocked. That is called half wave rectifier. Now construction of the half wave rectifier. So we want some components to construct this half wave rectifier, that is step down transformer, diode, load resistor and AC power supply. These are the four components required to construct the half wave rectifier. See now power supply. So this AC power supply is connected to the step down transformer. This primary winding of the step down transformer, and secondary winding provides the reduced voltage to the diode. One terminal of the secondary winding is connected to the anode of the diode, and cathode of the diode is connected to the load resistor. So other end of the load resistor is connected to the secondary winding. I am showing the construction of the half wave rectifier. So we are considering the primary winding and the step down transformer. See, step down transformer means the number of turns of coil is less in secondary winding. This comes under the step down, and when number of turns are more, it will comes under the step up transformer. So in the half wave rectifiers, we are using the step down transformer. See, for the primary winding, you are constructing the AC power supply, right? So 230 volts, 50 Hz in AC. And the secondary winding is connected to the anode of the diode. Cathode is connected to the resistor. And another end of the resistor is connected to the secondary winding. So this is the construction of half wave rectifier. This is the output in DC. Now we will see the working of half wave rectifier. See the working of half wave rectifier under the two conditions, that is during the positive half cycle and during the negative half cycle. So during the positive half cycle, the diode which is in the under the forward bias. So as we know, when the diode is under the forward bias, the diode will be and current flow will be done through the load, and this diode will act as a closed switch. Coming to the negative half cycle, in this case the diode is under the reverse bias. So when diode is under the reverse bias, there is no current flow and it will act as a open switch. The working of half wave rectifier is done. So we have two conditions, right? One is during the positive and during the negative half cycle. So during the positive half cycle means this is considered This is the X point and this is the Y. During the positive half cycle means, so this is positive and this is negative. See, this positive is connected to the anode. This is anode and this is cathode, right? And negative which is connected to the cathode. Means it the diode will act as the which is in the forward bias, right? So under the forward bias, the diode will be conduct and it will act as a closed switch. So how the waveforms are drawn for this means here I will show. So the input signal is same. So this is the input signal, right? So this is the input signal. So how it will conduct mean, see during the positive half cycle. During the positive half cycle, how the diode will conduct? So this is positive is connected to the anode, negative is connected to the cathode. So it will act as forward bias and the current flow will be done. So now how the graph will be there? So it will conduct during the positive half cycle. Coming to reverse bias. So coming to the second condition is the negative means X will act as a negative and this is positive, right? So this is negative is connected to the anode and positive is connected to the cathode. So now it will act as a reverse bias. So as you know, under the reverse bias, the diode will not conduct. So it will remain like this. So again, in forward bias, it is conduct and reverse bias, it will not conduct. Like that will be, the process will be continuous. This is, see here, these are the waveforms of the half wave rectifier. Means it will conduct under the positive half cycle. Now we will see the parameters of the half wave rectifier. First we will see the average value. So average value of current or voltage. So to find this average value of the current or voltage is also called as the DC value. Is also called as the DC value of current or voltage. So to find out this average value of the current or voltage, we have a formula that is I AVG means average. So it is also called as the DC value. So it's equal to IDC. So here I am writing the formula that is area under one cycle. Area under one cycle of the curve by base. So this is the formula to find out the average value of the both current and voltage. So now I average is equal to IDC. So area under one cycle of the curve means from the graph waveform. So this is our input signal, right? This is input signal and what we get in the output. So during the positive half cycle means this is pi, 2 pi, 3 pi, like that it will continue. This is 4 pi. So under from positive half cycle it will conduct and in the negative half cycle it will not conduct. So again in the positive cycle it will conduct, negative side it will not conduct. So this is 0, pi, 2 pi, 3 pi. See one cycle of the curve means we are considering from the 0 to 2 pi. So this is one complete cycle, right? So this is one complete cycle. So I am writing here that is 0 to 2 pi. Here we are find outing the current. So ID omega t by, so base is the 2 pi. So here 2 pi is the constant term. So bring the 2 pi outside. So 1 by 2 pi into 0 to 2 pi ID omega t. So now as we know, see the working, when we see the working of this half wave rectifier during the 0 to pi means from the 0 to pi it will conduct and from the pi to 2 pi it is not conducting. So first split this. So how we can split this? So 1 by 2 pi integral 0 to pi id omega t plus integral pi to 2 pi id omega t. So as we know, the value of the I is equal to Im sin omega t. So here from the 0 to pi it is conducting. So here in place of I we should write this. So is equal to 1 by 2 pi integral 0 to pi. What is the value of I? It is Im sin omega t. So Im sin omega t is for 0 to pi. From the pi to 2 pi it is 0. Why? Because it is not conducting. So plus integral pi to 2 pi it is 0. No need to write. So here Im is the constant term. So bring this Im outside. So Im by 2 pi integral 0 to pi sin omega t. So what is the value for integral sin omega t? That is minus cos cos omega t. So now apply the integrals. What we get? Im by 2 pi minus of now cos pi minus cos 0. So as we know, cos pi value is minus 1. Cos pi value is minus 1. Cos 0 value is 1. So right here is equal to Im by 2 pi minus is there. What is the cos pi value is minus 1 and minus cos 0 value is 1. So Im by 2 pi minus of minus 2. So Im by 2 pi minus to minus plus 2. 2 will get cancel and Im by pi. So this is the value, means average value. IAVG, it is also called as the DC value. What is the value for average current? That is Im by pi. So if you want to find it for the voltage, means it is nothing but VDC is equal to Vm by pi. So this is the average value for both current and voltage. That's it for today's video. So in next video we'll continue the parameters, that is efficiency, RMS value, ripple factor and the transformer realization factor, peak inverse voltage, and also we discuss the disadvantages of the half wave rectifier in the next video. So up to now I hope you understand the concepts very clearly. So I hope you enjoyed this video. Please like, share and leave a comment below, and don't forget to subscribe my YouTube channel for more updates. Thank you for watching. See you in the next video.